In this video, we'll talk about multiplying radicals. And we've used the formula before, n root of a times n root of b equals n root of a times b, a longer root. So you can read this formula from left to right, which means if you have more radicals of the same index, you can write it as a one long radical. Or if you have one long radical, you can separate it in more radicals, as long as you have multiplication between the terms. So, example 1, it's square root of 2 times square root of 2. Based on the formula, it's square root of 2 times 2, which is square root of 4, which is 2. So the same way, square root of 3 times square root of 3 is going to be square root of 9, which is 3. Square root of 5 times square root of 5 is going to be square root of 25, which is 5. Square root of 4 times square root of 4 is going to be square root of 16, which is 4, and so on. Example 2, it's square root of 2 times square root of 3, which is square root of 6, and I cannot simplify it further. Example 4, we have square root of 15 times 21, so we can multiply them and see if we have a perfect square, but since I don't have a calculator, I'm going to do 15 is 3 times 5 and 21 is 3 times 7, so I can immediately see that square root of 3 times 3 is 9, and then 5 and 7 are not perfect squares. If we multiply them together, they are still not going to give us a perfect square. So separating using the formula that I highlighted in yellow is going to be square root of 9 times square root of 35, which is 3 square root of 35. Final answer, right? 35, 5 times 7. I cannot separate it further or simplify it further. Example 5, we have 7 square root of 10 times 2 square root of 5. So there is multiplication between all the terms. So we will multiply 7 times 2 together, 14. So the number is outside the radical. And the numbers inside the radical together, because we have the same index, right? It's 2 on both of them. So it's going to be a 10 times 5, which is 50. Now, 50 can be written in 5 times 10, 25 times 2. So I'm going to choose the 25 times 2 because we can write it as a perfect square. So square root of 25, it's 5, and square root of 2 stays under the root. So this gives us 70 square root of 2 simplified. Simplest form. Now, let's take a look at example 6. So we have 2 cube root of 5 y squared times 4 cube root of 75y. So we will multiply the 2 times 4, which is 8. And then we have both of them are cube root. So we will make a bigger cube root where we put all the terms. So it's going to be 5y squared times 75y. So 8 times, don't forget the 8, right? Cube root of 5 times 75. We can multiply that, or I can write 5 times 75 can be written 25 times 3, and y squared times y to the first, it's y to the third, right? Properties of exponents, very important. 8 times cube root of 5 times 25, it's actually 5 to the third, or 125. I'm going to write y to the third, and then 3. I switch the order of these two factors. 8 times cube, well, now we can actually compute them. So cube root of 5 to the third, because the index and the exponent are the same, gives us just 5. Cube root of y to the third gives us just y. But this term here, it's going to be cube root of 3, and it stays inside. So in the end, it's 40y cube root of 3. That's final answer. So in the previous examples, we multiplied two terms, one term by another term. If we look at example 7, for example, we have one factor, right, to be multiplied by 2 terms. So it's going to be 2 square root of 10 times square root of 10, and then 2 square root of 10 times 3. So basically this should remind you of problems with polynomials, like if you had, for example, 2 times x plus y, you would multiply 2 with each of the terms. So we would get 2x plus 2y. So the same process applies here. So 2 square root of 10 times square root of 10 plus 2 square root of 10 times 3, right? So this 2 square root of 10 will be multiplied by both of the terms from inside the parentheses, and we had plus between them, so we get plus. So now let's simplify them. Now 2 times square root of 10 times square root of 10, it's square root of 100, which is just 10, plus 2 times 3, it's 6 square root of 10. So we get 20 plus 6 square root of 10. And if you are thinking to add 20 plus 6 and get 26, we cannot, because between 6 and square root of 10, it's multiplication. So we cannot add before multiplying. So this would be final answer. So this would be the work and then our final answer. And now let's take a look at example 8 that deals also with letters. So again, we apply the same principle, and it's going to give us 4 square root of x times 2 square root of x, it's 8x, because square root of x times square root of x is square root of x squared. The indices and the index and the exponent cancels, and we would get x. We want to make sure it's positive, so we can put absolute value of x. But I'm going to put here x is greater than or equal to 0, which is pretty much the assumption for all our variables in this type of problems. And then 4 square root of x times, and then we have minus, so I copy minus, and 4 square root of x times 3 square root of y is 12 square root of xy. No like terms, so we will stop here. This would be our final answer. Now let's take a look at 9. Well, 9 has 2 terms on one parenthesis and 2 terms on the other. So what we are going to do is, I hope you remember doing something like this with polynomials or binomials. X plus 2 times x, or 2x minus 3, for example. How did we multiply them? Well, x with each of them, 2 with each of them, right? So the same thing happens here with the radicals. So square root of 3 is multiplied with both terms from the second parenthesis. So we have square root of 3 times 2 square root of 3 minus square root of 3 times square root of 5. Now we are multiplying the 2. So because we have pluses there, it's plus 2 square root of 5 times 2 square root of 3. And then plus 2 square root of 5 times negative, it's negative 2 square root of 5 times square root of 5. And all we do here is simplify. So we get 1 times 2, 2. Square root of 3 times square root of 3, square root of 9, which is 3. Minus square root of 3 times square root of 5, it's square root of 15. 2 square root of 5 times 2 square root of 3 is plus 4 square root of 15. And then minus 2 times square root of 5 times square root of 5, it's 5. So we get 6 negative square root of 15 plus 4 square root of 15. Well, in front of square root of 15, it's a negative 1. So negative 1 plus 4, it's plus 3 square root of 15 minus 2 times 5, 10. So we get 6 minus 10, negative 4, plus 3 square root of 15. And that's the final answer. No like terms again, because it's 3 times square root of 15. All right, let's do example 10. So example 10, we have 2 square root of x plus 3 square root of y times 3 square root of x minus 4 square root of y. So let's multiply 2 square root of x by each of them. So we get 6 times x, right? Square root of x times square root of x. Again, we assume x and y are positive. So we did the first one. Minus 2 times 4, 8, square root of x times square root of y is square root of xy. Now let's do the second one. 3 square root of y times 3 square root of x and 3 square root of y times negative 4 square root of y. So 3 square root of y times 3 square root of x, it's plus 9 square root of yx or xy multiplication, it's commutative. And 3 times negative 4 is negative 12. Square root of y times square root of y, it's square root of y squared, which we just say y because x and y are positive. So now we get 6x. These two are alike, so negative 8 plus 9, it's plus 1 square root of xy minus 12y, and the only thing I'm going to do is just write square root of xy instead of, I'm just going to eliminate the 1 because it doesn't make any difference. I just put it only to emphasize that these two are alike terms, and when added together, negative 8 plus 9, it's positive 1. All right, and let's take a look at a few more problems. And I want you to pause the video and I want you to look at each of these problems and see if it reminds you of any of the formulas that we've done before in this class. Okay, I hope you found them. So the first one is a minus b times a plus b is a squared minus b squared. Very important formula. In our case, a is square root of 3 and b is square root of 2. Do you see how we actually have them? So what does the formula say? Well, it says that that product is square root of 3 squared minus square root of 2 squared. But square root of 3 squared means square root of 3 times square root of 3, which is square root of 9, so it's 3. 3 minus 2 gives us 1. If you take a look at problem 12, you should see or identify the same formula again, a plus b, a minus b. So a plus b times a minus b, it's a squared, so 2 square root of 3 squared minus square root of 5 squared. Now squared means you multiply the number by itself. So 2 square root of 3 times 2 square root of 3, it's 4 times 3. Minus 5, so we get 12 minus 5, which is 7. So for problem 11 and 12, we actually use the formula a minus b, a plus b equals a squared minus b squared, which was learned when we talked about polynomials, difference of two squares, right? So how about 13? Did you find the formula for this one? A plus b squared, which is a squared plus 2ab plus b squared. So in our case, a is square root of 3 and b is x. So using the formula, we get square root of 3 squared plus 2 square root of 3 times x plus x squared. Square root of 3 squared is just 3. This x is outside the radical, right? Because it's this x, it doesn't have radical. So we get plus 2x square root of 3. We usually write the terms without radical in front of the terms with radical. Plus x squared, no like terms, we stop here. How about problem 14? Did you identify the formula a minus b squared? It's a squared minus 2ab plus b squared. Be very careful. These are popular formulas that pop up in many math classes, not in just algebra. So our a is x square root of 2 and our b is 4. So we get x square root of 2 squared minus 2x square root of 2 times 4 plus 4 squared. So x square root of 2 squared means x square root of 2 times x square root of 2. X times x, it's x squared. Square root of 2 times square root of 2, it's 2. So it's 2x squared. So here I put 2x squared minus 2 times 4, 8x square root of 2 plus 16, no like terms, and we stop here.